Hi everybody, it's very nice to see you here in such a large number. Today we'll talk about Patrol, which is our new open source UI testing framework for Flutter. I'm Bartek, I'm a developer at LeanCode and I've been working on Patrol for over a year now. And yeah, that's Mateusz.
And I'm Mateusz, head of mobile at LeanCode. Nice to see you all. And in Patrol, I'm a technical product owner since day one of the project. And you can find me at this Twitter handle. So the first question I got for you is, who heard of Patrol? Heard of. Okay, nice. And who used Patrol at least once? Tried or just used Patrol CLI? Okay, nice. So for those who used it, we have Max and rewards in our booth, LeanCode booth, number 7. So you can come right after the talk and claim your reward for Patrol users. And who didn't use it, I hope that after this talk you will try to use it. So the agenda and our idea for this talk is to talk about the problem we approached with end-to-end Flutter UI testing. Then we will explore existing solutions and we will say how and why we ended up developing our own solution, which is Patrol.
Yeah, so what's the problem? Why are we even here? Because before we can talk about any solution, we need to understand the problem first very well. And the problem is basically that we realized that there's no good enough UI testing framework for Flutter in the market. And we came to that conclusion after researching the already available tools that are in the market. And we found that they have really severe problems. And they don't work well for Flutter at production scale. So what are these problems? Let's take a look. And we found two problems. The first problem, and that's the most annoying, the worst problem, is the inability to interact with native UI. And the second one, a bit less important but still annoying, is that test code that we write in our tests is too verbose. So let's say that you're writing an end-to-end UI integration test in your Flutter app and it works well. You are doing taps, enter text, scrolling, and it's all nice until that guy appears, the native permission request dialog. And it's a very sad moment when that happens because it's effectively the end of your test. You cannot dismiss that dialog, you cannot accept it, you cannot interact with it in any way. And that dialog is the most glaring example of Flutter, of native UI blocking Flutter UI and making your test impossible to progress, but there are more. So another very common case is a web view, right? Almost every app has a web view at some point. And the problem with web view is that from Flutter's perspective, it's a platform view and its contents are completely opaque. So you cannot interact with them in any way again, and that's really bad, right? And also another common issue are authentication flows. For example, sign in with Apple, sign in with Google. They are using native UI, not Flutter UI, so you cannot interact with them in any way. And that's the first problem, the most painful one, but there's also the second one, which is verbose code. So the snippet that you see here, it's a simple sign-up test that enters text into some text fields, then checks some checkboxes and performs assertions afterwards. And the problem with this test is that it's really verbose. And I think that if you weren't a Flutter developer, I bet you'd have a hard time understanding what even happens here and why there is that call to pump and settle in basically every second line, right? So annoying, and why it's even there. So it's not a great experience like since the beginning, but it gets worse. So the more complex, the larger your app gets, the more complex finders in your tests you will have to write. And so if you have quite a deep widget tree, you will have to reach for that finder.ancestor and finder.descendant. And after 2 or 3 levels of such nested finders, you can't even decipher what it is doing. It's so hard to read. And of course, they don't happen that often, but nevertheless, in more complex apps, more complex tests, they do happen, and we'd rather not have to write that very long verbose code ourselves. And of course, we didn't start developing Patrol ourselves right after we found those problems. We turned out to find existing solutions. So the first solution that of course exists is the default tooling, and that includes basically the free packages from Flutter. And in Flutter there are basically three types of tests. So we have unit tests for testing Flutter independent business logic in isolation. You also have widget tests for testing Flutter dependent UI logic in isolation. And if you want not to test in isolation, if you want to run a real app, then you have to use Flutter test in combination with the integration test plugin. And for every type of test, yeah, there's a package. So the first package is the test package, and it's nothing fancy. It's basically just the cornerstone of testing in Dart, and it's great. On top of the test package, there is the Flutter test package, which is a core Dart package from Flutter team. It's maintained by Google. It's located in the main Flutter repository. And in general, it's really great. It teaches the test package how to interact with the widget tree, with the element tree, render object tree, all these Flutter specific concepts. So it's basically kind of like an enabling technology, but it's not really great for writing end-to-end business flows. It's a great low-level API, not so much a high-level testing API. And yeah, it only works for widget tests. So the widget tests are tests that run your app in a headless environment, kind of like a headless browser, for example. And that's not great for integration testing. That's not an integration test. To actually run our real app, just like a real user would do it, we have to use the integration test package in combination with Flutter test. And now we're getting to the important and interesting stuff, integration test. And that's the name of the package, and it sounds really cool and serious, like integration test, right? But in reality, that package is really small, really minimal, and it doesn't contain that lot of code. It basically has two responsibilities. The first one is to make your tests run in a real app, and that's what this very nicely named class integration test widgets Flutter binding is for. And the second thing that the integration test package does is that it bridges native world of testing with Flutter world of testing. So practically speaking, what you get by using the integration test package is that you can run your Flutter tests written in Dart, and you can get test results in a format that native platform can understand. So in case of Android, that's JUnit XML, and in case of iOS, that's XC result. And these formats are really popular, and all the native tooling can understand it. So integration test package, it's kind of a bridge with the native world. But why even do we want to bridge our Flutter tests with native world of testing? Why do we want to be able to use native tooling? And the answer is that there's really a lot of native tooling, like really a lot of, and that's because Android and iOS, they have existed for more than 15 years now. And during that time, the companies, communities, individual people have created really tons of useful testing tools, frameworks, device labs, whatever, everything basically. And it's a great ecosystem that native developers can take advantage of, but the problem is that none of these work with Flutter out of the box, because Flutter is still quite a new framework, and it's kind of an island. It doesn't work well with the outside world, so to say. But of course, we would like to be able to use all that tooling. As Flutter developers, we don't want to reinvent the wheel. We want to be able to take advantage of what's already existing. And there are a few solutions on how we can accomplish that, but the easiest and the most sensible one is to create a bridge. So to wrap our Dart/Flutter tests into native tests, so that the native tooling will see our Dart and Flutter tests as native tests, but in reality, these native tests, all that they will do will be to start a Dart test and get its result. And it's basically a win-win situation for us and for all these native tools, because they get new users. And So yeah, we need a bridge, and the integration test package is kind of that bridge, but it's not a perfect one. It's got many problems, and it hasn't received any significant updates since it was released, I think, 2 years ago in Flutter 2.0. So yeah, the first problem that the integration test package plugin has are unnecessary builds. So let's say that you have 100 tests in your application, and to run all these tests, you have to build the application binary 100 times. And like, this is really a huge pain in the neck, because the integration tests, they are slow by themselves. They often take hours to execute, but now we also have to spend additional hours to build them. It just doesn't make any sense. And also it messes up test reporting. So for example, on Firebase Test Lab, because we have a single test in a single app binary, not all tests in a single app binary, we get this not very nice, not readable, fractured and fragmented test report. We can't easily see at a glance which tests passed, which tests failed. It's annoying. And this problem has a workaround. But it's a very insidious and annoying workaround, and we call it primitive test bundling. So it's really primitive. What we do is we create a file called bundle test or something like that, and inside that file we import all the other tests. And it works great, thanks to us importing all the other tests and registering them in that graph. All those tests get compiled into the app binary at the build time. So we get all tests in a single app binary, and then we can upload that app binary easily to some Firebase Test Lab, for example. And the code looks elegant. It's a very simple solution. It also fixes that fractured, fragmented test reports, but it has a very significant flaw. And to find that flaw, let's explore what happens. What happens when a test fails and when a test crashes. So let's see what happens when a test fails. Here we have a few tests, so time flows from top to bottom. Let's say that alpha test is executed first, then Bravo test is executed, and in this case, Bravo test fails, maybe because some assertion failed. And well, nothing bad really happens at this point. We execute subsequent tests and we get a nice test report. So, okay, so far. But the problem is with the native crash. So let's say that this time Bravo test didn't fail, it crashed. So maybe that's because of some native exception being thrown in plugin native Java code, some null pointer exception or bad memory access in Objective-C code. And like, this is the problem with this approach, with this workaround, because all these tests, they run and their state lives in a single app process. So when we kill the process of the app, and that's effectively what a crash is, it calls exit. And if you exit your app process, like, the app dies and the tests also die. You lose test state of your test suite. And the worst thing is that subsequent tests aren't executed because, well, the process died, there's nothing more to do. And you also don't get any test report because it's generated after all tests execute, but this time that didn't happen because it died. So it's really very, very annoying, and there are more problems, but this is the most important annoying one. Also, you get no sharding when you are using the integration test plugin. So sharding, for those of you who don't know, is a process of splitting your test suite across workers that run in parallel in the cloud, so you can get a very significant speed up for your tests. But because of the way the integration test plugin is implemented, sharding doesn't work. And also another annoying problem, a little bit smaller than the previous ones, but still annoying, is that all your tests will always take 1 second to execute. Again, because of how bare bones the integration test plugin is. It would be great, but it's unfortunately not the truth. And yeah, at this point we knew that the default tooling cannot satisfy our needs, that we need to look for something different. And that's what Mateusz will tell you about.
Yes, so we found out that the most popular end-to-end UI testing framework for mobile apps in the market is Appium. Also, one of our clients was heavily using it. So we thought with our Flutter Enterprise app, we also thought, okay, so let's give it a try. So Appium is the most popular open source mobile UI testing framework. It's a black box testing solution so that you don't know the code. You can't use any of the, you can take advantage of knowing the code. You are just clicking on the app, and there's no official support for Flutter. The best thing we have is a project called Appium Flutter Driver, which is maintained by a single person, and we admire that person. Kudos to them, because they do an amazing job. But the problem is that it's the whole approach of this black box testing uses Flutter Driver, which is not actively developed anymore. And since it's a black box approach, we can't take advantage of being a Flutter app and knowing the Flutter code base, so we can't wait for an animation to stop. We can only interact with the widget tree as long as Flutter Driver allows us to. Also, with Appium, device farms have to support it explicitly, since it has a complex architecture, and for example, it doesn't work with Firebase Test Lab. So just to give you a glimpse of the architecture, in Appium, we can write tests in other languages, but not Dart, at least officially. You have to run some Appium server. You have to have some networking enabled so that you can send requests to your server, and then the server communicates through so-called drivers, which can be native, as you can see at the screen, or Appium Flutter Driver to the device. So everything is really black box. So with Appium Flutter Driver, we have those issues that first thing is, since you don't have the code base and you are not in the Dart runtime, everything is weakly typed. So you have to just put strings anywhere and hope that it will work. If the developer changes the key or some other stuff, your test will just fail, and you will just have to know about it and know how to fix it. Also, if you are familiar with Flutter test finders and you write widget tests, then you know that there are a lot of nice finders in there. But unfortunately, Flutter Driver only can handle a subset of the finders from Flutter test, which is called common finders. So not all of them are exposed via API. So if something is not exposed through Flutter Driver, then it cannot be used with Appium, because that's the design of the solution. And also some features don't work properly, and if properly, I mean not as you would expect from the Flutter widget test point of view. For example, we had to re-implement scrolling, and as you can see, I added the stars that we needed to fork Flutter test. We needed to fork Appium Flutter Driver. Also, you cannot find first because there are workarounds for that, but you can't just find first widget, or if there are multiple widgets and you want to just go through them, you will also get a crash, because it's just something that's unexpected from the Flutter Driver perspective, and your test fails. So we thought this is unacceptable, and we as Flutter community can do better, and we deserve some UI testing framework that's up to standards and production grade. So we thought, okay, no one wants to write their own testing framework, so we ended up writing our own testing framework, which is Patrol, Flutter First UI testing framework. And what it means, Flutter First, is that it's dedicated for Flutter apps, because Flutter apps are 99% of Flutter code, right? Like Flutter code-based Flutter views, and only we want to be enabled to go through these native obstacles. It's not like the Flutter app, it's not like testing mainly native code. We still want to be comfortable with Flutter. We want to be comfortable with Dart and our own code base of the app. So it's written in Dart, and it's made for Flutter apps, because if you write Flutter apps, you know Dart. So why not writing everything in Dart, since we are already in the same runtime and all? So it uses Flutter Test for Flutter features, because as Bartek said, Flutter Test is a great low-level API for interacting with the widget tree and all of the lifecycle of the widgets. So we should use it. And also for native UI, we leverage native test frameworks to also use official ways to do that, which is UI Automator on Android and XUI tests on iOS. And we want to offer smart defaults. And what it means is that in our company at LeanCode, we have a QA engineering team, and they write automated tests, and they write UI end-to-end UI tests. And they, for example, they don't care about what it means to settle. Like, this is a term that only we know as developers. They just want to, you know, find this text and tap on it. Scroll to that text and tap on it. And I want to see this text. And that's over. They don't care about settling, pumping some frames. What does it even mean for them, right? Because it's not something that's intuitive. It's only intuitive for us because we already know about it, but it's not intuitive for everyone. So we thought, okay, so let's try to make a framework that's readable for someone who is just an engineer, not a Flutter engineer. And also, like, we thought that majority of cases you want to do like the same thing. For example, find first, like 99% of times you want to find first if there are multiple things. Maybe you don't want, then you can change that. Or for example, you want to wait, I don't know, a second or two, or a couple of frames. So why doing so? We can do it for you. And also we got inspired by a couple of frameworks, and you will see it in a bit. So that you can write only the code that matters. And the most important thing, as Bartek said, we would like to be compatible with the native tooling, because the worst issue with Flutter from our perspective is that the native developers can use like thousands of tools and everything that the world offers, and we have to check if it supports Flutter. This really sucks. We would like to be just comfortable with using any tool that is already in the market, because, for example, a customer can come and say, okay, we use Test Trail, or we use AWS Device Farm, or something like that. And does Flutter support it? And we don't want to answer that. We have to answer, yeah, we support all the native tooling. It doesn't matter for us. So that's our goal. Okay, so let's go to, yeah.
So here is how the rough architecture or dependency diagram of Patrol looks like, and how it interacts with what Flutter gives us out of the box. So at the bottom we still have that test package, and then on the top of this package we still have the Flutter test package. But this time Flutter test comes with improved API, which comes from Patrol, because we are not happy with the verbose code that we write with Flutter test, so we improved it. And on the top, there is no more integration test. We yeeted it. It wasn't great. And we replace the integration test plugin with the Patrol plugin. So what are Patrol's features? And of course, the first most important feature is the native automation feature. So it finally allows you to interact with all these native UI elements in your apps. It's no longer a problem. Let's see how that looks like in code. So the code, that snippet, it doesn't differ much from a normal widget test in Flutter, except that you use the Patrol test instead of the test widgets function. And the type of object you get is not a Patrol tester, it's not a widget tester, it's a Patrol tester. And Patrol tester is really the object that gives you superpowers. So it lets you interact with all these permissions, web views, and basically everything that is native. And it's all normal, pure Dart. You don't have to learn another language or write XML or YAML. You just use Dart for your tests, which we think is great. And let's take a look at a few most common use cases. So of course permissions, and they just work out of the box. Like you have that $, which is Patrol tester, and you simply call $.native.grant permission when in use, for example, and it does exactly what you would expect it to do. It just works. It's that simple. Also notifications. We weren't able to interact with notifications before, and now we are, thanks to that $.native.open notifications method. And then we can just slide down the notification shade and interact with notifications just like we interact with all other native UI. And then we can So if we tap on notification, we can go back to our app and assert that some state has changed in response to tap on that notification. So really, really cool. And another common feature is location permission. As you all know, the location permission dialog on the more modern Android and iOS versions, it's not a simple yes/no. It's you also can select the granularity of location data that you are giving to your app and when that app has access to your location data. So it's a slightly more involved, but because it's such a common feature, we package it in Patrol out of the box for you. So you can simply do that $native.select find location or select course location, and again it does exactly what you would expect it would do. And so after seeing this, I hope that you are probably thinking like, wow, this is awesome. Finally, I can interact with all that native stuff, and now I will automate everything. And that's certainly possible. Here you can see a test that creates contacts in a native contacts app on some Google Pixel emulator. And it's written fully in Dart in Patrol. And it works. But we are here to tell you that moderation is a virtue, and that you shouldn't maybe use our native automation feature all the time, because it introduces a dependency on the applications that you are testing. So that test, it might work in this particular contacts app on a Google Pixel emulator on vanilla Android, but it would most certainly fail on some Samsung phone, because that's just a whole different contacts app, right? And in general, depending on too much of code that is not yours is just a bad testing practice. So try to minimize that situations. So that was it for native automation. And now we're getting to custom finders. So we were also not happy with how verbose the test code is. And we thought well, let's improve how the API looks like. And we came up with something like that. So we can enter text like this and also tap very easily. And we believe that this syntax, this API, is much easier to read, write, understand, and comprehend for people, especially for people who are not very intimate with Flutter and who are not like Flutter developers, very experienced developers. How our custom finders work under the hood is they basically, in simple non-nested cases like these ones, they map, it's basically a switch over the argument type. So they map to Flutter test finders like one to one.
Can I ask one question?
Sure.
Maybe someone knows why we used a $sign. Yes, exactly. It was inspiration by the good old jQuery. We thought that we would like a function to just, find anything.
Yeah. So, yeah. And apart from how much shorter our custom finders are, they also have a better behavior out of the box. So let's talk about that now. But before that, let's compare how much shorter and easier to read our custom finders are. So on the left, that's the same test. It's a simple sign up test that again enters some text in forms and stuff like that, nothing fancy. Very simple stuff, basically. But it took 23 lines, or basically even 24 in a Flutter test to write that test, and with Patrol, it's, I think, 9 lines. So huge size reduction, and I think we hope that it's much easier to read, write, and understand. And apart from how much shorter our custom finders are, they also have, we hope, better behavior out of the box. So in apps, you often download some data from the web, and that involves always a little waiting. So you have some loading indicator that is spinning. And it may be silly, but in Flutter test, by default, you don't have any function that would wait until a widget is visible. It just doesn't exist. And that's what this to-do comment is for. It's not that I forgot. It's just, if I were to implement that function here, it wouldn't fit the screen. And also you have to remember about pump and settle after you interact. And you also have to remember to enter .first in that finder, because if you don't, and there are 2 subscribed texts, or 3, not 1, it will also fail. Like that's how Flutter test works. It fails if there is more than 1 widget found. So you have to remember about that first. And all these flaws are fixed with the line on the right, with the Patrol custom finders line. It's much shorter. It automatically waits until that subscribe button in a list view becomes visible. It handles pump and settling itself, and it looks cool. And yeah, as your size of your custom finders grows with default Flutter test, it becomes more and more ridiculous pretty fast. So you can easily reach that kind of free nested finders. And I'm not even trying to understand what happens here. It takes a good chunk of time to understand that. But the same thing can be expressed with patrol on the right in a single line. So here we are trying to tap on a widget with key learn more, and that widget has to be inside a list tile, widget with type list tile, and we want that list tile to also contain a widget with text activated. So it can be expressed in a single line, and yeah, that's great as well. And another great feature of our custom finders is that they don't replace what's already in Flutter test. Instead, they build on top of it. So if you want, you can easily access a widget tester like that, and you can also use default Flutter finders if you want, for whatever reason, maybe for migration or something like that. So you get access to all the native tools that already exists. I mean, all Flutter test tools that already exists, but you also can start using patrol. And in general, that's our philosophy, kind of, to not replace, but to extend. And also, I complained about how the integration test package isn't maybe the best plugin out of there. And I'm happy to say that Patrol is also an improved version of integration test plugin. So all these problems and that most important problem with many builds per test, it's solved in Patrol as well. And it's a very cool thing that we did. Basically, we also solved that isolation between tests problem. So now you can have all your tests in a single app binary, so you no longer spend hours and hours building them. You can you can build it just once, and then you can run all these tests in one invocation of testing. But all these tests run in isolation, and we achieved that by running our Flutter tests in a separate app process on each invocation. But all state of the test suite lives inside the instrumentation process, and that involved quite a lot of playing with native automation tooling like XUI test and UI Automator and Android Test Orchestrator. And unfortunately, I don't have enough time to talk about this right now, but I have written quite a lengthy article. It's available on the LeanCode blog, so I invite you to check it out. And also sharding, it works out of the box with Patrol. Also test durations, they are fixed as well. And we also have hot restart, so you get that nice development experience that you are used to in Flutter. You can basically type Patrol develop, and then you type R, and your test restarts from the beginning. It's really cool, and it really speeds up the execution time. Yeah.
Yeah, so let's talk about support. Yeah, so Patrol is an open source framework on Apache license, so you can just use it, fork it, and do whatever you want. We have something that we call extensive docs, but I don't know if it's true. Patrol.leancode.co. And also, like, what's the main support is that we developed Patrol for our own purposes, because our QA engineering team had those issues and those blockers about native automation. So we use it like on a day-to-day basis in our production grade apps, and we just deliver tests for our clients with this framework. So you mustn't trust anybody, I know, but you got to trust somebody. That's how this world is constructed. So you can trust us that we will maintain it because we still need it and we still have to develop it for our clients. So yeah, to wrap it up, thank you for being here. And you can help us. We encourage you to do so. You can like the package on Pub. You can give us a star. I've seen before the talk that we had 398 stars, so maybe we can do more than 400. You can follow us on Twitter, and you can contribute. This is, I think, the most helpful thing, and we'll love that. issue and file issues, fix docs, contribute to discussions on GitHub. We have discussions enabled and people are proposing a lot of stuff. And of course, the most important thing is to use it and give us the feedback, because you know, we think that this is cool, but maybe you will use it and say to us that, okay, but I don't need half of it, or for example, I need some other feature, and we will know what to do and what to prioritize and all this stuff. Yeah, also, if you want to get a reward, we have a contest for you. You can come to our LeanCode booth number 7, and if you do a puzzle and solve it using Patrol, then you get a reward. So I encourage you to go right after this talk to our LeanCode booth. I think that's all, right, Bartek?
Yeah, that's all. I think we have 4 more minutes. So are there any questions?
Yeah, so thanks a lot.
Yeah.